Hey, when you have a 30, 60, 90 triangle, one angle is a right angle, one angle is 30 degrees, and the other is 60 degrees. Now, it really doesn't matter. The 30 degrees could be on top and the 60 could be on the bottom. It does not matter which one is the 30, which one is the 60. So now what you're going to do, let's name this triangle. Let's name it ABC. Hey, I want you to look at the 30-degree angle. Can somebody identify for me which side is across from the 30-degree angle? Which side is across from the 30-degree angle? Nora. AB. The side that is across from the 30-degree angle, we call it X. All right, now let's look at the 60-degree angle. Someone identify for me which side is across from the 60-degree angle. Michael? BC. So the side that's across from the 60-degree angle, we're going to call that X root 3. Then you're going to look at the 90-degree angle and you're going to identify which side is across from the 90-degree angle or the right angle. Dimitri? AC. And that is going to be 2X. Now, it does not matter which angle is the 30-degree angle, because now let's say, same thing, but now let's say I put the 30-degree angle on top and the 60-degree angle on the bottom. Let's name this QRS. This time, what's happening? This time, the side across from the 30 is not QR. This time, the side across from the 30 is RS, which we're going to call X. And the side across from the 60 is X root 3, which is QR. And still the side across from the 90 will be QS, which is 2X. So it's not always that the vertical line is X and the horizontal line on the bottom is X root 3. No, you look for the angles, you decide which side is across from those angles. All right, so how does this work? How does this work? Scroll down. So now I have a triangle. One angle is 90, one angle is 30. Do I know for certain that that last angle has to be 60? Yeah, because you have to add up to 180. So now we're going to memorize. We have to memorize the 30, 60, 90 triangle. And we're going to say, okay, well, let's call this ABC. Which side is across from the 30? Isn't it AB? We're going to label that with an X. The side across from the 60, which is BC, I'm going to label that with X root 3. And the side across from the 90, which is AC, I'm going to label that with a 2X. Everybody okay with how I labeled this? So now what you want to do is you want to choose the side that has a variable and a side length. So, for example, BC only has a variable expression, the X root 3. It doesn't have a side length. AC only has the variable expression, which is 2X. It doesn't have a side length. But AB does. It has the variable expression X, and what else does it have? A side length of 4. You set your variable expression equal to your side length. So I'm going to say X is equal to 4. Is there anything to solve? There's nothing to solve. It's telling me X equals 4. So now that I know that X equals 4, I can find the other two sides. So AC is going to be 2 times 4, which is 8. And BC is going to be 4 times root 3, which is just 4 root 3. Do we already have a side length for AB? Yeah, what is it? 4. So there's no plugging in to find AB. It's already 4. Ethan, was your hand up? No? Okay. All right, next one, number 2. Okay, so once again, I have a 90 and a 60, so I know this is a 30, 60, 90 triangle. You all tell me, which side am I labeling X? Which side am I labeling X? Which side is x? Oh, should I give it letters? Q, R, S. Which side is x? Yeah? RS is x. The side across from the 30 is x. All right, which side am I labeling x root 3? Lexi? QS is x root 3. And which side am I labeling 2x? Side am I labeling 2x? Well, QR. So now what do? We choose the side that has a side length and a variable expression. Which side has a side length and a variable expression? Nora? Yep, QR. So we have 2x and we have 10. So what do? We set our side length equal to the variable expression. So 2x equals 10. Is there something to solve now? Absolutely. I can divide by 2, and then I get x is equal to 5. Which side is 5? Which side will be 5? RS is 5. And what about QS? What's that going to be? What's QS going to be? Nora? 5 root 3. All right, number 3. Once again, I know we have a 30, 60, 90 triangle. Across from the 30, I'm labeling with X. Across from the 60, I'm going to label with X root 3. And across from the 90, I will label with 2X. We choose the side that has a side length and a variable expression, which is that height vertical segment. And you set your variable expression equal to your side length. So I'm going to write x root 3 is equal to 7 root 3. We need to solve for x. Do we all agree in order to solve for x, I need to divide by root 3? So I need to divide by root 3 on both sides, but what happens to that root 3 on both sides? On both sides, they cancel. So what am I left with? X is equal to 7. So that means the bottom side is 7. What is the hypotenuse going to be? 14. Ethan, you good? Yeah, I'm just looking. All right, number 4. Stepping it up just a tiny bit. So again, we know this is a 30, 60, 90 triangle. The side across from the 30, I'm labeling with X. The side across from the 60, I'm labeling with X root 3. And the side across from the 90, I am labeling with 2X. All right, so Demetri?
Can you also multiply by root 3 on both sides and then divide x by 3?
Absolutely. Absolutely, you can do that. All right, so now what we're going to do is we're going to choose the side that has a side length and a variable expression. In that scenario, it's the bottom side. So what am I setting equal to each other? I'm going to say x root 3 is equal to 6. We need to solve for x. So I'm going to keep the x. I'm going to divide by root 3. But think back to when I reviewed radicals with you all. Am I ever allowed to leave a radical in the denominator? No, that means we need to rationalize this denominator. Who remembers how we rationalize the denominator? Kaylee? You multiply it by itself. So now I'm going to multiply the bottom by root 3 and the numerator by root 3. So I end up getting x equals 6 root 3 in our numerator. What's root 3 times root 3? Whole number 3. I'm not done. Why am I not done? we can simplify. 6 root 3 divided by 3 is going to be 2 root 3. So what does that mean? Our vertical side is 2 root 3 because that's x, so this is 2 root 3. What is my hypotenuse going to be? Hypotenuse is going to be 2 times 2 root 3. What's 2 times 2 root 3? 4 root 3. You got it. Do we all see how this works? Great. I'm sorry? Oh, the bottom one, we're not plugging in, right? Because it already has a side length of 6. How about you guys try independent number 6 on your own? Try independent number 6 on your own, and then we'll go through it. Are we ready to go over this? All right, so what's happening here? So I know this again is a 30, 60, 90. Opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. What do? We choose the side that has a variable expression and a side length. We set them equal to each other. So here we're going to have x root 3 equals 16. We're solving for x, so we're dividing by root 3. So now we get x equals 16 over root 3, but we remember we can never leave a radical in the denominator. So now we rationalize, multiply by root 3 top and bottom. So now we're going to get x is equal to 16 root 3 over 3. Is it okay that I cannot simplify the 16 and the 3? That's absolutely fine. We don't have to. So what does that mean? The height here is 16 root 3 over 3, our x expression. And then our hypotenuse is 2 times 16 root 3 over 3. Well, 2 times 16, isn't that 32? So this is 32 root 3 over 3. And then the other side, we don't have to find. There, it's already there. It's 16. How many people got that correct? That's it. Everybody else, did you find your mistake? Figure out what we did? Do you want to try another one then? Okay, go back to number 5 and do number 5 then before we move on to 45, 45, 90. All right, are we ready? Let's go over this. So again, this is a 30, 60, 90. So we have across from the 30 is x, across from the 60 is x root 3, across from the 90 is 2x. So now we have x root 3 equals 5. Divide by root 3. We get x equals 5 over root 3. But once again, what do we have to do? Rationalize. So we end up with x equals 5 root 3 over 3. Is it okay that our denominator doesn't divide into the numerator? Yes, you leave it just like that. So again, this height is 5 root 3 over 3. That's that side. My hypotenuse is going to be 2 times 5 root 3 over 3. What's 2 times 5 root 3 over 3? 10 root 3 over 3. So our hypotenuse is 10 root 3 over 3. What is the side length of that last side? 5. There's no plugging in there. There's already a side length there. Are we ready to move on to the next set of triangles? So we did the Pythagorean theorem, we did Pythagorean triples, we did 30, 60, 90. The last special kind of triangle we are going to learn about is a 45, 45, 90 triangle. So think back to our proofs. Do you guys all agree I now have a triangle with 2 angles congruent? If I have a triangle with 2 angles congruent, what else do we have? If you have a triangle with 2 angles congruent, you have 2 legs congruent. Good, Will. We have 2 legs congruent. So the sides that are across from the 45s, A, B, C. Tell me which sides are across from the 45s? Which 2 sides are across from them? You got it, A, B, and B, C. So those are the sides that are going to be congruent. The 2 sides that are congruent we call X and X, and the side across from the 90-degree angle, the hypotenuse, is not 2X. It is going to be X times root 2. Do you think you need to memorize these triangles, the 30, 60, 90, and 45, 45, 90? Absolutely. All right, let's do some practice with the 45, 45, 90. So I have one angle's 90, one angle's 45. Because a triangle has to add up to 180, we know the last angle also has to be 45. So now we're dealing with a 45, 45, 90 triangle. Across from the 45s are both x, because if the base angles are congruent, the legs are congruent. And the side across from the 90 is x root 2. Similar to the 30, 60, 90, you're going to find the side that has a side length and a variable expression. Which side has a side length and the variable expression? The 15. You set them equal to each other. So x equals 15. There's no solving. It's just x equals 15 in this scenario. So that means the other x side is 15. What about the hypotenuse? What's the hypotenuse going to be?
15 root 2.
Good, Jeff. 15 root 2. All right, number 2. Again, we're dealing with a 45, 45, 90. Across from the 45s are x's. Across from the 90 is x root 2. You take the side that has a variable expression and a side length, and you set them equal to each other. So x root 2 equals 8 root 2. We need to solve for x, so we divide by root 2. But what happens to the root 2's on both sides? They cancel. Good. So x equals 8. So that means both side legs are 8. We already have the hypotenuse, which is 8 root 2. We're not plugging in. All right, number 3. Again, we're dealing with a 45, 45, 90 triangle. Across from the 45s are x and x. Across from the 90 is x root 2. Can somebody set up the equation for me that I'm going to use to solve for x? What's the equation we're going to use to solve for x? Annalena, what's the equation we're going to use to solve for x? You got it. X root 2 equals 13. Now we're going to solve, so we're going to divide by root 2. Can I leave it like this? No. What must I do? Rationalize. So I'm going to multiply by root 2, top and bottom. So x equals 13 root 2 over 2. Is it okay that I cannot divide 13 and 2? Absolutely, that's perfectly fine. So both legs are 13 root 2 over 2, 13 root 2 over 2. The hypotenuse is already there. It is 13. All right, so now I'm going to throw a little curveball at you and make things, not, in my opinion, it's not harder, but students always think too fast on this one and that's where they usually mess up. So now, again, we're dealing with 45, 45, so it's x, x, x root 2. We choose the side that has a side length and a variable expression. So here we're going to have x is equal to 10 root 2. Is there anything to solve? No. Does x equal 10 or does x equal 10 root 2? 10 root 2. X does not equal 10. X equals the full 10 root 2. So a lot of times students go to put in for the hypotenuse and they just write 10 root 2. It's not 10 root 2 on the hypotenuse. The hypotenuse is x times root 2. X times root 2. Well, my x is 10 root 2. So this is 10 root 2 times root 2. What's root 2 times root 2? 2. So this becomes 10 times 2, which is 20. Our hypotenuse is 20. What's the other leg? So we know one leg's 10 root 2. What's the other one going to be? 10 root 2. All right, let's look at number 5. How do I know number 5 is a 45, 45, 90? Demetri? Excellent. Remember, if we have a triangle with the legs congruent, aren't the base angles also congruent? So the only way this works, because I have one angle that's 90 and the other two angles congruent, is if both those angles are 45. Does that make sense to everyone? So now what do we have again? X, x, x root 2. You're going to take the side length that has a side length and a variable expression and set them equal to each other. So we get x root 2 equals 4. We divide by root 2. So we get x is equal to 4 over root 2. What should we do now? Multiply by root 2. This time, can I simplify the 4 and the 2? Yes, so we get x is equal to 2 root 2. So both legs are 2 root 2. All right, I want you to do number 6 by yourself, and then we're going to move on to some more difficult problems, bringing quadrilaterals back into things.
Go to the bathroom.
You may. All right, so what do we have? We are having 45, 45, 90, x, x root 2. Do we all agree that x is equal to 3 root 5? Right, that is not the hypotenuse. What is the hypotenuse? The hypotenuse is x times root 2. So this is 3 root 5 times root 2. What is 3 root 5 times root 2? 3 root 10. And do we agree the other leg is 3 root 5? How many people got that? Good. All right. So now we are bringing this in back with the quadrilaterals. We're bringing this back to the quadrilaterals. It says if the perimeter of a square is 36, find the length of a diagonal. If the perimeter of a square is 36, find the length of a diagonal. All right, so we need to remember a couple of things. Things about a square. Well, in a square, aren't all sides congruent? So when it says the perimeter is 36, that means each side has to be 9. Then it says find the length of a diagonal. Guys, you understand, because I was getting a lot of questions on the 9496 quiz. A diagonal has to go from one vertex to the other vertex, right? That's a diagonal. When we have, don't draw this, but just to confirm, when you draw on your other diagonal, this highlighted yellow portion, is that called a diagonal? No, this highlighted yellow portion is not called a diagonal. People think, I was getting questions like this is a diagonal. This part is not a diagonal. A diagonal has to go from vertex to vertex. This is just part of a diagonal. It's not a full diagonal on its own. All right. Draw, let's erase that. We don't need that. We only needed one diagonal. All right, what else do we have to remember? We need to remember that in a square, all angles are right angles. There's one more thing that would be really helpful here to remember. Michael?
The diagonals bisect the angles.
Good. In a square, the diagonals bisect the angles. Because they bisect the angles, aren't we left with 45, 45, 90 triangles? All right, so they want us to find the length of the diagonal. When we find the length of the diagonal, I'm going to use just one of these right triangles that I've created. So I will redraw it. I have a 9, I have a 9, and I want to find the hypotenuse. So I remember in a 45, 45, 90 triangle, opposite the 45s are x, opposite the 90 is x root 2. You choose a side that has a side length and a variable expression. Well, I have two sides that have a side length and a variable expression. Is that okay? Yeah, absolutely. You just choose one of them. X equals 9. If x is equal to 9, what is the hypotenuse? 9 root 2. Isn't the hypotenuse the diagonal? So the diagonal equals 9 root 2. All right, number 2, it says find the perimeter of the rectangle. All right, what do we need to remember in a rectangle? Not all sides are congruent, opposite sides are congruent. So how am I going to find the length of these opposite sides? I'm going to choose one of these triangles. Does it matter which triangle I choose? No. Oh, also, all angles are right angles in a rectangle. All right, I'm going to choose, I'll choose this bottom one. I'll choose this one. We can redraw it if you like. So this is a 30, 60, 90. I know we just learned this, but who remembers across from the 30 is what? Since you're all going to have to memorize this anyway. Across from the 30 is x. Across from the 60 is x root 3. Across from the 90 is 2x. Good. So what are we going to do? We're going to choose the side that has a variable expression and a side length, set them equal to each other. 2x equals 10, so x will equal 5. Hey, what does that mean? That means the left side is 5. What is the right side going to be? Or the bottom side, I should say. The left side is 5. What's the bottom side of this triangle? 5 root 3. Good symmetry. All right, so now going back to the rectangle. If the left side is 5, the right side also has to be 5. If the bottom side of this triangle is 5 root 3, what's the top side of the rectangle? 5 root 3. So the perimeter is going to add up all the sides. 5 plus 5 is 10. 5 root 3 plus 5 root 3 is 10 root 3. I cannot add 10 and 10 root 3, so I leave it just like that. All right, let's keep going here. Couple more problems. So, given isosceles trapezoid EFGH, legs EF and GH, what does that mean for us? Because it's isosceles, these legs must be congruent. Then it's telling us that angle F is 45 degrees. If angle F is 45 degrees, which other angle has to be 45 degrees? G has to be 45 degrees. We want to find the perimeter. This 16 represents F to G. That's 16. I do not have enough information right now to find the perimeter. Does anybody have any ideas on what I'm going to do? Okay. Excellent. I'm going to make an altitude from E to, I don't know, W, and from H to P. So now what have I created? I've created two right triangles, and what shape in the middle? A rectangle. If it's a 10 on top of the rectangle, what's the bottom part of the rectangle? Also 10, which leaves how many units left over? 6. Are these triangles congruent? Yes. So if they're congruent and there's 6 units left over, don't they each get 3 of it? So we're 3 and 3. All right, going now using one of my triangles. Let's use this one. This ends up being a 45, 45, 90 triangle. Opposite the 45s are x and x. Opposite the 90 is x root 3. Do we agree here that x has to equal 3? Because of this, x equals 3. So the altitude is 3. What's the hypotenuse? Oh, why did I do x root 3? It's x root. Nobody caught that? Should be x root 2 for a 45, 45, 90. Nobody even called me out on that. Come on, guys. All right, so my altitude is 3. What's the hypotenuse going to be? 3 root 2. If FE is 3 root 2, which other side is 3 root 2? Good, Mia. HG is 3 root 2. So now can I find the perimeter? Absolutely. I'm going to add my whole number. So 16 bottom place plus 10 top base is 26. Then I'm going to add the 2 legs. What's 3 root 2 plus 3 root 2? 6 root 2. We good for the next one? So now we've talked about the square, the rectangle, the rhombus. The last one that will ever show up, sorry, we talked about the square, the rectangle, the trapezoid. The last one that will show up for you is a rhombus. The last quadrilateral that could potentially show up for you is the rhombus. So what do we need to remember? One of the angles of a rhombus is 120 degrees. If the perimeter is 24, find each diagonal. All right, remember, is this yellow a diagonal? No, diagonal has to go from vertex to vertex, vertex to vertex. I'm going to give some letters here so we can address them. Let's call this A, B, C, D. Let's call where the 2 diagonals intersect point E. So then it's saying one of the angles is 120. Do you think it matters which angle you label as 120? No, I'm going to say that A is 120 degrees. We need to remember, in a rhombus, what do the diagonals do to the angles? They bisect them. There is no doing this problem without remembering that. So if the full angle is 120, each part of it has to be 60. The diagonals bisect the angles. All right. Then it's saying the perimeter is 24. So what else do we have to remember? In a rhombus, all sides are congruent. So if the perimeter is 24, each side has to be 6. All right, other things we have to remember. It says find each diagonal. We have to remember that not only are the diagonals perpendicular, which means 4 right angles in the middle, also the diagonals bisect each other. So AE is congruent to EC, and DE is congruent to EB. All right, what am I going to do to figure this out? Do you all notice how I have a triangle that has a 60 and a 90 in it? We have 2 triangles that are labeled 60 and 90. I'm going to choose this triangle right up here. Everybody okay with what I've done so far? All right, I'm going to redraw this triangle. E, A, B. There's my right angle. There's my 60 degrees. EB is 6. And now I know this is a 30, 60, 90 triangle. Opposite the 30 is X, that's AE. Opposite the 60, which is BE, is X root 3. And opposite the 90 is 2X. You're going to choose the side that has a side length and a variable expression and set them equal to each other. So 2X is equal to 6. Therefore, X is equal to 3. This makes a difference. If AE is 3, which other segment has to be 3? If AE is 3, which other one has to be 3? EC. And then what is EB? If X is 3, what is EB? AJ, what's EB? No, X is 3. EB is X root 3. So what is that? 3 root 3. So EB is 3 root 3. If EB is 3 root 3, which other segment is 3 root 3? DE. So now when they say find each diagonal, they mean the full diagonal. So the first diagonal is not 3. The first diagonal is 3 plus 3, which is 6. I called that D1. Then diagonal 2 is not 3 root 3. Diagonal 2 is going to be 3 root 3 plus 3 root 3, which is 6 root 3. You got it. All right, our last question for today. All right, so we want to find CD, AC, AD. In order to do this, we have, do you all notice, we actually have 3 right triangles. Do you see that? We have DCB as a right triangle. We have ADC as a right triangle. What is my last right triangle? What's the last right triangle and how do you know? Nobody? Really? Jeff?
ABC.
ABC, good. How did you know that's also a right triangle?
Angle A is 30 and angle B is 60.
You got it. Angle A is 30, angle B 60. The only way to add up to 180 is if that angle ACB is 90. So those are our 3 right triangles. Hey, let's go. We want to find CD. In order to find CD, do you all agree we're going to have to use the yellow triangle? How come I know I have to use the yellow triangle and I can't use the blue triangle? Any ideas? How do I know I have to use the yellow and I can't use the blue? AJ. Good, because it has a side length. The blue triangle has no side lengths in it. So I'm going to go ahead and I'm going to pull out my yellow triangle here. This ends up being a 30, 60, 90. Opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. Oh, sorry, I didn't label that. CB is 12. So you choose the number that has the side length and a variable expression. We set them equal to each other. So 2x equals 12, so x will equal 6. That means DB is 6, and DC is 6 root 3. So DB is 6, CD is 6 root 3. So when it says find CD, we got 6 root 3. Now we have our choices. Which triangle do you want to use to find AC? Whatever you guys want, that's what I'll use. Which triangle do you want to use to find AC? Do we want to use the blue one or the big one?
Blue one.
Blue one? Okay, thank you. Let's use the blue one. So the blue one, I'm working with that upside down triangle, ADC. Now I know CD is 6 root 3. I have 30 degrees, 60, 90. Opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. You choose the side that has a side length and a variable expression. So I end up getting x is equal to 6 root 3. Now AC, isn't that 2x? So what am I going to do? I'm going to do 2 times 6 root 3. What's 2 times 6 root 3? Somebody, anybody? What's 2 times 6 root 3? Michael? 12 root 3. I hope you're all just tired and not forgetting your radical rules. So AC is 12 root 3. But then they're asking us to find AD. Well, we're still in this triangle for AD. Isn't AD x root 3? Okay, now be very careful. This is x times root 3. But what is my x? My x is not 6. My x is 6 root 3. What is 6 root 3 times root 3? 18. That's 6 times 3, which is 18. There you go. All right, so I'm actually going to have your homework not be the textbook pages. I'm going to actually have this be your homework, this worksheet, and we're done.